All right, a lot of people have asked us what we're doing for the new chassis design on the Camaro, and they wanted us to talk about some chassis design concepts that we use when we're working on the car and other cars in the shop. So the first thing that I normally do when I'm doing a design like this is we'll get it up on our chassis table, and the good thing about the chassis table is I've got the axle center line drawn on the table, and then I've got a square center line down the whole center of the car, and the car is up here and it's centered on the table, and the axle centers are in the right location for the body. That's basically going to be the datum points that everything else comes off of. So you really want to make sure that you got good solid datum points to work off of. And for us, it's the longitudinal chassis center and the axle center lines. That's the starting point. So now that we've got the car there, we've got it blocked up on, we've actually got blocks of steel underneath it that are holding the chassis at ride height. So the way the chassis is going to be sitting at ride height is the way that it's sitting on the table now. So all of our geometry is based around that. After that, this car has already had a lot of time on the geometry, so we know where the pickup points need to be. I know where the lower control arm pickups and the upper control arm pickups and everything are going to be located. So once we kind of have that, we start designing the structure. So this car already had a structure in place that got damaged, and we're kind of rebuilding a new style front structure that attaches to the old front structure pickup points. All right, so one of the things that's kind of tricky is, and you got to play a balancing act on, is the pickup points, where they are in space versus where you can actually support them properly. We're kind of going to do something interesting, and I want this chassis to be able to support all-wheel drive. So to do that, I have to be really careful of what's in the way of a diff that'll eventually live right here. So I can't have my coilover running right down the middle of my control arm anymore, because the old pickup point used to be right on the center of the axle center, because that's exactly where the coilover was mounted, and it went down to the control arm right there. Now we need to offset all that stuff to the rear to make where we have the clearance for a half shaft to run through there. So we're going to run a rocker system on it now. So the rocker pickup point is going to become my target for where a lot of load is going to go through. So we're going to make the main node for the loads in the front of the chassis be the rocker pickup point. If you notice, we have a motor plate here. The motor plate is going to have to be supported well, so there's going to end up being a vertical 1 5/8 095 chromoly tube that the motor plate mounts to. That point is going to be triangulated with some gusseting through here to the 1 5/8 tube that runs across the top. So basically this whole side of the frame up here is going to be like a major frame rail that'll act as a truss, and it'll be tied in to the motor plate, which is going to act as a shear plate. And what that does is this plate, when it's loaded in compression and tension, is not going to want to give. It's not going to let this brace deflect. So by the time we're done with all of that, this is going to be a really, really, really strong structure, and it's going to hold shape very well. And then the front here, we're planning on having just a grip of aero in the future on this thing, and massive loads. You know, the front of this car can see over 2,000 pounds of aero loading. So that's another reason we're doing this truss look, is so that when the aero load is transferred through the chassis, it's able to handle over double the weight of the car. All right, so kind of show you the front view. One of the trick things we're doing on the chassis this time is we've narrowed the lower frame rails significantly, and then created kind of an air space in here. That's actually being done for aerodynamic purposes. So In the past, we kind of just looked at the chassis as a strong structure that supported the pickup points for the suspension. Now, we're looking at it as the structure that has to support the aerodynamics, and the suspension just needs to be out of the way. So it's kind of interesting. We know that we have some nice proven geometry. We're happy with it, so we know we don't want to mess with that. But we do want to increase our ability to add a bunch of downforce. The previous chassis had a lot of limitations there. We didn't have room for airflow and cooling and all of the other things that we want to do. So this new design is going to be much better for that. It offers a lot more space and open area for airflow. We're actually moving a lot of the suspension components higher in the chassis, which, if you think about it just from that perspective, from CG height, all that, you're thinking, well, that's a bad idea. Why do you want to move the CG height up? Well, the benefits from the aerodynamics far outweigh the losses that we're going to incur by raising the CG height slightly on the car. So the forces that we're talking about aerodynamically are not duplicatable through just geometry. We're going to be able to generate more grip with aero than we are with just mechanical grip on geometry. So that's why where you make those compromises is kind of an art form, and it's always changing. You're always learning and moving forward, and that's what keeps us going, and that's what makes this fun, is that you're never going to have the perfect right answer because it's an artistic balance.